Now we are going to evaluate this double integral using the change of order of integration. You are given evaluate double integral between the limits 0 to a and x to a, and the f of xy is given as x square plus y square dy dx. Now this can be written as integral 0 to a, and you can have this x to a x square plus y square dy. You can give the curly brackets now, which means that the problem is given to integrate with respect to y first between the limits x to a, and then finally integrate with respect to x. So whenever you are given the problem to integrate with respect to y first, which means that they have given the y strip. Y strip is nothing but the vertical strip in the region. And now for change of order, I have to change the order and then integrate. For that, I have to consider the horizontal strip, because they have given the vertical strip in the region. Now for the change of order, now I should change the order in such a way that I have to integrate with respect to x first and then with respect to y. So in order to integrate with respect to x first, we have to consider the x strip, which is nothing but the horizontal strip. And before we consider the strip in the region, we have to locate the region. We have to shade the region in which the integration is going to be done. Now, as per this given double integral, you are given the x limits are from 0 to a and y limits are from x to a. So, when x equal to 0, this will imply y axis, and when x equal to a, this is a line parallel to y axis, and y equal to x, it is a straight line passing through the origin. And y equal to a, again this is a straight line parallel to x axis. So in the xy plane, suppose you are given suppose you have an xy plane. So this is your xy plane. So this is my x axis, y axis, and this is the origin, and x equal to 0 is the y axis. So this is the line x equal to 0, and x equal to a, suppose I have a point a, x equal to a on the x axis. If you draw a line, straight line parallel to y axis, so this will represent the line x equal to a. And now y equal to x is a straight line passing through the origin. So this y equal to x is in the form of y equal to mx. When m is positive, the line will pass through the origin through the first and the third quadrant. When m is negative, the line will again pass through the origin, but it will pass through the second and the fourth quadrant. Here m is 1, which is positive, so it is a straight line passing through the origin. So I have a straight line, I can draw a straight line passing through the origin. So this is my line y equal to x. And now y equal to a is a straight line parallel to x axis, and it will pass through the value a on the y axis. And before we check, when we draw a line parallel to x axis, we should know whether it passes through this point of intersection or below the point of intersection or above the point of intersection. For that, I should get the point, and this is the intersection of x equal to a and the line y equal to x. When I substitute x equal to a in this line, y equal to x, y equal to a also. So this is the point a comma a. So the line parallel to x axis, which is y equal to a, will pass through this point of intersection. So this is y equal to a, and this is the point a on the y-axis. And now I should know which region has to be shaded, whether this upper triangle or the lower triangle. As per the given double integral, they have given in such a way that we are integrating with respect to y first and then with respect to x. So when we integrate with respect to y first, which means they have given the vertical strip, so the end points of the vertical strip in the region will give you the y limits. So the lower end point of the vertical strip is lying on y equal to x. It is sitting on y equal to x, and the upper end of the vertical strip is on the line y equal to a. So where can we find? Suppose I have my vertical strip here. Suppose you have your vertical strip here. The lower end point of the vertical strip is on the x-axis. So the equation of x-axis y equal to 0. Upper limit or upper end point of the y strip or the vertical strip is on the line y equal to x. So the limits of y will be the end points of the vertical strip, which is from 0 to x, but my limits of y is from x to a. So when I have my vertical strip here in this upper triangle, I find the lower end point of the y strip is on y equal to x line, and the upper end point is on the line y equal to a. And for the limits of x, you have to move the y strip from left end to the right end towards in this direction from left to right. So when you're moving, swiping or moving from left end to right end in such a way that the strip has to completely wipe the portion, the upper triangle. So now when you move it, swipe it from left end to right end, you find the x limits will move from x equal to 0 to x equal to a, and therefore my region of integration is this. So this is the region of integration in which they have given the y vertical strip. Now we have to change the order. In order to change the order, I am going to consider the horizontal strip. Once you locate the region and once you know what strip they have given, we can now change the order. For that I am going to have the horizontal strip. Horizontal strip is otherwise the x strip. So let me draw an horizontal strip in the region shaded. Now I am going to write the limits for x. So the end points of the x strip will give me the x limits. So my x limits are going to be here. My x limits are, it is the left end point is at x equal to 0 to the right end point of the horizontal strip is on the line x equal to y. So the limits of x are from 0 to y. And now I am going to find the y limits. To get the y limits, I have to swipe or I have to move the horizontal strip from the lower end to the upper end in such a way that it covers the complete shaded portion. So from this point origin to this line, I have to move the horizontal strip. So at this point y is 0 and at this end y is a. So these are the limits for y. And now the given integral, suppose you are considering the given integral as I. So now I will be equal to, you are going to have x square plus y square, and now we are going to integrate with respect to x first and then with respect to y. Now for the inner integral I have to give the x limits. So the x limits are from 0 to y, 0 to y, and the outer integral will go for the y limits. So the outer integral will have the limits from 0 to here y equal to a. So from 0 to a. Now when you integrate, now I am going to integrate the inner integral with respect to x, which means I have to treat y constant. So integral 0 to a, my x square dx will give me x cube by 3, and y square dx plus y square dx is, y square is a constant, integral dx will give me x between the limits 0 to y, and then I have to keep this dy out. And now I have to apply the upper limit minus lower limit for the variable x, right? So when you are giving the upper limit here, the upper limit is going to be y cube by 3 plus, now for the variable x it is y, already one y square is there, y square times y will give me y cube, and minus the lower limit is going to be 0, right? And then I'll have my dy out. And now integral 0 to a, now y cube by 3 plus y cube will give me 4y cube by 3 dy, and this is equal to, I can take 4 by 3 out, integral y cube with respect to y will be y4 by 4 between the limits 0 to a, and this 4 I can cancel. And when you apply the limits for y now, upper limit minus the lower limit, so the upper limit is 1 by 3 out, and upper limit for y4 is a4 minus the lower limit is 0. So finally I am getting the value a4 by 3.